Okay, let's start the lesson.
hmm
So you are doing radians and reference angle, this kind of stuff at school.
Yeah.
Okay, which
Uh, Hold on. Can you zoom what are radians? We haven't got here yet.
mhm.
We are mainly on here, let me show you our syllabus so far.
Okay.
Am I able to screen share?
Um, okay, you can try. If the access is not given, then I need to go back on main session, then I will give you the access. Can you please try?
Okay. All right. Yeah, it works. Let
Okay.
me uh let me go to my thing. So we're mainly like this unit, like advanced functions. We're
Mm-hmm.
basically like doing stuff like linear functions, quadratic functions, factoring quadratics, parabolas, asymptotes. And this unit, we
Mm-hmm.
mainly go into asymptotes like 1 over x minus h.
Okay.
So these are end behaviors, intervals, how
Okay.
to graph an asymptote. Hopefully this is like a bit familiar.
Yeah.
Do you want?
Okay. Okay, you can share this file with me if you want to discuss this so we can discuss.
Okay.
Is it
How do
possible?
I share it with you, by the way? Do you want me to just send you a picture?
Um, I think I got the different unit, right? Three, chapter three is different. I have different one. Okay.
This should be the course. I mean, the thing is the same. It's just
Yeah, I got
no,
this one.
this one's yeah, this one's different. Characteristics of a function, domain and range. No. This is the one that like we mainly use at school. It's the most familiar.
Okay. Okay. You want to discuss the asymptotes and the other stuff like that?
Yeah.
Okay. Send me the picture of that. Which thing you want to discuss? Okay, so that will be better.
Okay, I'm gonna just start off with 3.1.
Or you just need to go there. I will take the screenshot.
Are you gonna take a screenshot? Okay. I'll try to get one without the class notes. Is that okay? Or
Okay. Uh,
I think I
okay.
sent you the pictures, no? On WhatsApp through my
No,
mom's phone.
no, I didn't get. I think. Let me check. One second. I think I have these pictures. Yeah, I have this. Wait, I didn't check this. Okay, you can stop sharing
Do
this
you
with
want
me.
me to?
No, no,
Okay.
it's okay. Oh, I already have. One second. Just give me 1 minute. Let me download this and paste here.
It's all good. So 3.1 is reciprocal of a linear function,
Hmm.
reciprocal of a quadratic function, rational functions. The formula is f of x equals ax plus b cx plus d. solve rational equations and inequalities, and
Okay.
that's mainly
What
it.
is the difference between linear function and quadratic function?
Um, a linear function is mainly like a straight line. Quadratic can be like a parabola and
Yeah, I
that
got you.
shape.
But I mean to say, like, what's the difference between their equations? Like, how the linear equation is different than the quadratic equation if we are not talking about the graph. Yes.
Power,
Yeah,
exponent,
exactly. What is the exponent, highest exponent in linear?
1.
One, and in quadratic we have a two, right? It's a basic thing. Okay, we have to start from this page, right?
Hmm.
Okay, these are rational functions. Oh, which functions are called rational functions?
Rational function. Uh, I'm not sure.
In
Like the
which,
definition of it, I'm not sure.
okay, any counter example, a function which is, will not
Rational
be an
function.
irrational function, like,
No. All I know is like 1 over
mhm.
x minus h and then.
Okay, a function in which all the exponents are um, positive integers. Okay,
Okay.
like here, whenever you will see the exponent here, exponent is one, here exponent, and we will check the numerator separately. Is this a rational? If this is rational, yeah, we will say if both numerator and denominator are rational, so we'll say this whole function is a rational. Okay, and
Okay.
what this is a rational or not? How we'll check it out? We'll check exponents of the variable. If all the exponents of variables are positive integers, like not 1 over 2, we don't have the root of a variable. Like if we have a square root of x plus 7 over x plus 9, it looks like a function, yeah, but it's not a rational function. Why? What's the problem? Because
The
it's
root,
numer. Yeah, that's why. Here you can see, even they mention that, explain why each function is not a rational. See, they give us the example,
hmm
and so we can understand from here. And they said that a is equal to f of x is equal to x plus 5 over 4, right?
hmm
Why it's not
x
a
plus
rational?
5 over 4 because there's no x value on the denominator.
Yeah, no, wait. I think this is a rational function. Why it's not rational? This makes sense, like we have a square root in it. Can you please check, is this the function x plus 5 over 4, or we have something different in it
Okay.
from
X plus
your,
5 over 4.
yeah, it's the same.
Yeah.
This is a rational number, rational function,
So how would you determine if it's rational or not?
because its numerator is a rational and denominator is also a rational. We can say it's 1 over 4 x plus 5 over 4, right? This is a rational. Yeah, it's a rational.
1 over x, take the x out, times plus. Okay.
If it was, yeah, it is a rational function. I don't know why they replacing this one irrational. It is a rational function. This was irrational function because in this one, this is the only contradiction we have. Okay.
Okay.
Next, we have how are the graphs of a function and its reciprocal function related? Okay. So yeah, definitely this is a linear function. Graph f of
First
x is,
one? Yeah.
yeah, this is a linear, and this makes sense. It's a linear equation. So its graph will be a straight line, and this is a reciprocal function. So its graph will be hyperbola.
Okay.
On Desmos and compare the y value of corresponding positions on each curve.
Uh, we don't really need to do that. That's
Yeah,
just
We just need to use Desmos graphing calculator to sketch it.
Hmm.
Simple. Okay, the most important feature that distinguishes the graphs of the rational function is the presence of the asymptote. An asymptote is a line that graphs approaches more and more closely but never touch. So in this function, we will not get any asymptote. We can sketch it on Desmos graphing calculator. X plus 5 over 4, right?
Hmm.
This was the function. See, even this is a linear function, you know, this is rational. It was not. If we will sketch the other function, which was square root of
Root.
x or something, square root of x and plus 5 over 2x plus 1 over 2x plus, so we can see its asymptote. It's a horizontal asymptote is a x-axis. This is a horizontal asymptote. Sometimes we have a vertical asymptote, but we don't have any vertical asymptote here. This is its horizontal asymptote, x-axis. It's
Yeah.
going, it's like moving closer to
To
closer and
zero,
closer.
but it
Yeah,
never touches.
yeah, that's it. So yeah, that's why. Okay, let's discuss the further. Next, we have the vertical asymptote. Vertical asymptote, like vertical line, is a line axis.
Why?
Yeah, it's not always like y-axis. Sometimes we have a y-axis, but sometimes we have like sometimes x minus 5, even any vertical line be asymptote. It depends on the function. Okay.
Okay. So x minus 5 vertical asymptote at
Yeah.
plus 5.
Yeah, any like line be a vertical asymptote, even x1, x2, x3, x5, any line will be a vertical asymptote. Let me show you.
Okay.
Like if we have a function y is equal to, let's suppose, y is equal to x plus 5 over x um, plus 5. No, let's take x plus 1. So here, what is the vertical asymptote? Its vertical asymptote is -1. From where we will get this one. Look, this function will be going to infinite when x is equal to -1 here. If we replace -1, what will be in the denominator?
0.
0. Whatever in the numerator, it will be 4, by the way. 4 over 0, what it will be? It will be approach to infinity, right? So that's why
Yeah.
at -1, we have a vertical asymptote. Here, this line is our, sorry, not this one. I mean, this line is our vertical asymptote.
Mm.
Does this make sense? It depends on the
Yeah, yeah,
function.
yeah.
Like if we'll change the function, let's suppose if I'm taking in the denominator x plus or let's suppose minus 3. So this time x is equal to 3 will be our vertical asymptote. Got it?
So at plus 3, the line in between the two asymptotes. Okay.
You can see here, this one is our vertical asymptote. Let me mark here. This is a
So
vertical.
I have a question. The denominator value or the factor in the denominator will always be the vertical asymptote?
Yeah, which
Okay.
makes the graph reaches to infinity. That will definitely will be 0 in the denominator. Those values which makes the function approaches to 0. Those values of x at which the function reach to infinity. Those are called vertical asymptotes.
Okay.
Okay. And in last graph, we get the horizontal asymptote. And what was that? Root x over 2x plus 1. So in that one, we get the horizontal asymptote. Okay. So vertical asymptote is a vertical line, x either x is equal to 0 or something, any. For the reciprocal function, like if we have 1 over x, so which value will make this function approach to infinity? Definitely x is equal to 0, right? Not -1, not any other value will
1
pro
divided by negative
like
1 is -1. Yeah.
yeah, it will give the proper value. Either it will be in a decimal, it doesn't matter. But if it will reach to 0, at which value it reaches to infinity? At 0, right? When x will be 0. Do you understand my point?
Because any number divided by 0 equals infinity. Yeah.
Yeah, exactly. Okay, so yeah, I think they are explaining here as well, and it represents the 0 in the denominator. That is the value for which the denominator is 0. And if denominator will be 0, definitely if we have something in the numerator, something over 0, whatever in the numerator, if the denominator is 0, it will gives us infinity, which we
Hmm.
cannot mark on the y-axis. A dashed line is used to represent the vertical asymptote, and notice the graph approaches more and more closely but never touches, like it up moving closely to -3 or 3, whatever the vertical asymptote. Let's suppose if I'm taking here x plus, it was a x minus 3. So what was the vertical asymptote? It was 3, right?
3.
3. So what does
3.
it mean? It means that when you
It
are,
gets closer to 3.
yeah, when we are moving the value of x closer to 3, either from right side, from left side. Okay, so we will get infinity value. Like if you are replacing negative, what was the function? It was x plus 5 over x minus 3, right? If
Minus
we
3.
if we
Yeah.
replace here from negative side means we are going to replace 2.999, right, in this function. So what will be its answer?
I didn't understand what you just said.
1 second, let me show you. Like this is the function, right? X plus 5 over x minus 3. In this one, if I will replace 2.99, what will be the answer?
As 2.9 as x,
Yeah, 2.99
uh,
plus 5 divided by
7.99 over 0.01, negative 0.01.
yeah. So what will be the
Mm.
answer?
Negative 2.95
It's
plus
negative.
5.
It's approaching to minus. So as we are approaching to negative to 3 from this side, as we are approaching to 3 from this side, so we are getting bigger number, negative 700. You can see it will be down here, right? Does this make
Hmm.
sense? If we'll approach to this
Yeah.
side, so we will get a bigger number, bigger and bigger
Bigger.
number as we are approaching to 3. Like 3, if you will replace 5, you will get a normal value 5 in this function. If you will replace 5, so what it will be? 5 plus 5, 10 over 5 minus 3, 2. So 10 over
2.
2, it's 5. So it's okay. But as you will move closer to 3 from this side, so you will get a bigger and bigger number. Okay. And at
Okay.
3, you will not get any value. It will be infinite. Okay. That's about the
Mm.
vertical asymptote.
Okay.
And if you are approaching to 3 from the left side, again, you will get bigger and bigger number.
Bigger, but it's negative.
Active. Yeah, in negative. Like here, I show you a negative for 2.99. So see, we were approaching to 3 from the left side. So we are getting, if you will approach more closer to it, let's suppose 2.99999. So it will be more bigger number. Definitely it will be in the denominator will be 0. negative 0.00001 something, right? So it's see, it's 79 million in negative. So it becomes more
Mm.
bigger number. I hope you
Okay.
understand my point.
Hmm.
Any question about vertical
All right.
asymptote?
Okay. Horizontal. Okay.
Okay, and next we have a horizontal asymptote. It's the same, we have a same debate. In this one, we just have a horizontal line. Is the line y is equal to 0 for the reciprocal function, and it helps with sketching the end behaviors, right and left ends. The end behavior is determined by what happens to the value of y as x becomes very large, means x approaching to infinity, how the function is behaving, and about which number it is reaching out.
So can we do the end behaviors for the last function in Desmos?
Mhm. In this one, like if, one second, let me open the Desmos calculator as well. Like here in this function, if x plus, if I'm taking x 40, 40 plus 3 needs to be divided by 40 minus 3, right? So value is approaching to what?
1.16.
So if I will take more bigger value, let's take 400. I'm taking x 400. So still value is approaching to 1. It means that it is approaching to 1, right?
Hmm.
So it means that what's the horizontal asymptote? Even you can take the values in negative, negative 400 and negative 400. So again, value is approaching to 1, but from
1.
the bottom side, right? So it's on this side.
Okay.
Is this make sense or not? So it's what's a horizontal asymptote here? X is equal to 1. Here, x is not a horizontal asymptote. Y is equal to 0 is not a horizontal asymptote. Here, y is equal to 1. Y is equal to 1. Where is y is equal to
Mm.
1? Let me sketch here. Y is equal to 1. This is our horizontal asymptote. Let me try if I can make this dotted line. No.
So
Yeah.
you just have to input the same value for x, and then you'll find out
Yeah.
the horizontal.
You just have to put the values bigger and bigger in x, take bigger and bigger value of x, okay, and take it out. This number is approaching to what? It will be clearly show you. You just have to use your calculator, and then also you can put that value, same value in the negative, and check it out. Like what
So
our
1 plus
function,
3.
how the function is behaving if we are replacing bigger values of x in positive and in negative. Which number it is approaching to which number? Okay.
So in this case, it's 1.
Yeah, in this case, it's 1 because
1 minus. Yeah.
we observe here with the bigger and bigger value. Even if you will replace 4,000, it will not give you value less than 4,000. See, 4,000. Still, it is 1.00. So what it is representing? It is representing like it is approaching to 1, but it will never gonna touch the 1. Okay.
So couldn't you put 1 for x? So 1 plus 3 over 1 minus 3.
If you will put 1, yeah, 1 and 1. So it's minus 2. So minus 2, when x is 1, here, this is the function. Somewhere here, this value. 1 minus 3. x1.
Oh, so that's the bottom. Okay.
Yeah, because we are approaching to 3 from the right side. So 3 is our vertical asymptote. If you will replace 3 here, so you will not get any value. Do you
Yeah,
understand it?
because it's zero.
It's gonna be vertical asymptote. The denominator will be 0. I already explained that concept. I hope you understand what is a vertical asymptote and what is a horizontal. Vertical asymptote, like
Yeah.
the function is approaching to that value, but it's never touched that value. Same debate for the horizontal asymptote. It is approaching to that value when x is, we will take x bigger value in positive or in negative. We will check it out how the function is behaving when x approaches to infinity, or x approaches to negative infinity. Like we just have to replace x bigger and bigger in positive and check it out. What's the behavior of the
Mhm.
function? It is approaching to which number? Okay, what
Okay.
number we are getting? If we are replacing x bigger and bigger in positive or in negative, it will be approached to same number, but one from the bottom side, and for the other one, it will be from the top side line. Got
Okay.
it?
Mhm.
Okay, that's the whole concept about vertical asymptote and horizontal asymptote. Here we have a domain range. What is a domain? I'm pretty sure you know about it. What is
XCR, all values of X.
uh, it depends on the function. Like domain means what we can replace. Like if I'm talking about the domain of this function, its domain is all real number except 3. Its domain is minus
All real
infinity
numbers.
to infinity, but excluding 3. Why I cannot replace 3 in it? Because then the function will be undefined.
Zero.
The denominator will be 0. Function will not be 0. Function will be undefined. We say function undefined because we are not getting a value. Undefined value we
Yeah.
are getting. Infinity, infinity is undefined.
Mhm.
We cannot say
One divided
infinity
by
is the
zero
bigger
is, yeah.
number. Yeah, it's undefined. So its domain, what we can replace in it? We can replace any value, any decimal, any value, or any integer except 3. So its domain is all real numbers except 3. There are many ways to write its domain. You can write like this, or you can simply just say all real numbers except 3. This is the better way. Even I will prefer this method. Okay.
How,
This
how
is
we
its
do it over here is we write XER so that X is is it less than 3 or what's the thing?
for range.
Uh for the domain.
This one will be its domain.
I'm just trying to tell you how we write it over here because I
Oh,
can
okay, okay,
write
okay.
it.
Okay, okay, sure. Yeah, there is another way to write the x. Like we can say x is greater than 3, greater than 3, or less than 3. Like this. You mean to say this?
Yeah, exactly.
Yeah, we can also use this method. So I told you there are many ways to write the domain and range. So they are expressing the same sentence or same thing. Okay, but we have a different way to represent it. Okay, next, like if the function is 1 over x, what will be its domain? They said that minus infinity to 0. Like we can take any value except 0. They are using a different way to represent it. You can also write like this: x must be greater than 0, and or x must be less than 0. Okay, or you can say
Yeah.
all real numbers except 0, because at 0 it will be undefined. And this thing also representing the same. How even they wrote the 0, it means that minus infinity to 0. Minus infinity. I hope you know about this open brackets. What's the meaning of open bracket and close bracket? Like if we have a square bracket, it means that the 0 is included. If we have a curve bracket, it means that 0 is not included. Okay, we cannot
Okay.
replace 0 in it. We can replace 0 negative 0.009, but we cannot replace 0. Okay, because this function
Okay.
will give you the value at 0.009, even in negative 0.00005. Even at smaller and smaller number, it will give you the value, but at zero, it will be undefined. So zero is excluded from its domain. So this is another way. What will be the range? So range is like what we get. Domain is what we can replace. Range is,
For X?
yeah, domain is X, like what we can replace in X, we can replace with X. So that is called its domain. And after
And range
replacing,
is the Y?
yeah, range is the Y, like what we get. Like if we substitute any value in it, so what we will get in at the end after solving it, that is called its range.
Okay. All right.
Intercepts, I'm pretty sure you know about it.
Y-intercept, like solve, put X to 0, and then,
Yeah,
yeah.
in this one we will get only one intercept. That will be at 0, 0. Its x-intercept will be 0 at, and y-intercept will also be at 0. And
Because it's linear, so yeah.
yeah, there will be just one x. And no, even in linear, sometimes if we have a, let's suppose the equation,
No, I'm saying the function Y equals
mm,
X.
yeah, for that one, we just have a one x-intercept, same x-intercept, and it is cutting the x-axis and y-axis at the same point. That is origin. But let's suppose if we have x plus 5, in this case, its x-intercept is positive 5 and y-intercept is negative 5. Sorry, I said oppositely. Its y-intercept is at 5 and x-intercept is at negative 5, right?
Okay. Because X plus 5 equals 0, X equals
Mhm.
minus 5, and then 0 plus 5.
Yeah, you need to substitute.
So,
You can also use that method, even though, but here we have a graph, so we can understand from the graph, like at which point it is cutting the x-axis and y-axis. There, those points are called its x-intercept and y. This point is at x-intercept because at this point it cuts the x-axis, and this point is called its y-intercept. Even if you will
because it cuts
calculate,
the.
with the method like you was using, like replace x is equal to 0 to find y-intercept, yeah, you will get the same value. You will get 0, 5, 0, 5 when you replace x 0. And for x-intercept, we need to replace y equal to 0, right? So when we replace y 0, so it will be written as minus 5 because you will get minus 5, and x will be written at first, minus 5, 0. So this is the same point. Do you understand my point?
Yeah, 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 definitely.
Okay. Okay, let's back to work. Next asymptote, we already discussed what are the asymptotes, and but here in this function, we don't have any asymptote. Okay, because this is a rational function. In this one, we don't have any asymptote. And this is a reciprocal function. In this one, there will be asymptote. X is equal to 0, vertical asymptote. That will be vertical. VA means vertical asymptote.
So when
And
X values
yeah,
approach, okay,
yeah, like here you can see 1 over x. So in this one, vertical asymptote, it is like when x is approaching to 0, either from right side, from left side, the value is approaching to infinity, undefined, the function going to be undefined. Okay, but at
okay,
exact 0, it will be undefined. So vertical asymptote is 0 and horizontal asymptote is also 0.
0.
And how we can find the horizontal asymptote? Horizontal asymptote is not that much easy. Vertical asymptote is easy. How we can find the, okay, this is a question. How we can find the vertical asymptote? Just check out.
Vertical asymptote is the factor on the denominator. Horizontal asymptote is the numerator, so like X plus 2
No, no,
over X plus 5. No? Okay.
no. A horizontal asymptote is not that much easy. Yeah, vertical asymptote are the factors of the denominator. That makes sense, like the values of x, which makes the denominator 0. But for horizontal asymptote, you need to check out the behavior of the function on x approaching to infinity or x approaching to minus infinity. Like what's the behavior of the function? It will be calculated. If I will replace x infinity here, 1 over infinity, to which number it is going to be approached? So it's mean that y is approaching to 0, right? 1 over infinity, it's 0.
Yeah.
Does this make sense?
Yeah.
And if I was stuck, if we had the same last function that I wrote in the starting, x plus 5 over x minus 3. Uh, okay, in this one, if I want to calculate the vertical asymptote is 3, right?
Mhm.
Horizontal asymptote. So I will replace infinity plus 5 over infinity minus 3, right?
Mhm.
So we can say infinity plus 5, as x approaches to infinity, y is approaching to what? So what will the value?
-3.
Look, we cannot use this technique, but we can just find out, like just replace in rough work, okay, not in neat. So
Okay.
infinity plus 5 or infinity minus 3, what will be the, if we'll add something in a very big number, what will happen? It will become more bigger and it will not that much effective, right? And same thing in the denominator. So it will be stay same. So what will be the answer? It's 1, right? So it means that as x approaching to infinity in this function, as x approaching to means I substitute x with infinity. As x
Yeah.
approaching to
Okay.
infinity, y is approaching to what?
Infinity.
No,
Oh,
y is
1.
approaching to 1. I show you here, right? So y is approaching, as x approaching to infinity, y is
Oh,
approaching
yeah,
to,
because y equals
yeah,
infinity over plus.
yeah,
Okay.
we don't have to do this work. We cannot substitute x with infinity. Infinity is not a number. Infinity is the undefined form. So y is approaching to 1. So it means that our horizontal asymptote is 1. We have to check with minus infinity as well. Is the y is approaching to 1 same as x approaching to negative infinity? So how we can check it out? You can uh, one by one put the negative values and bigger negative values. I mean, x negative 500, negative 1000, negative 2000, negative 5000, and then check out the behavior of the function that I showed you before. Like it was approaching to 1. It was
Yeah.
0.99. So even you can calculate like this. This is the other method. So negative
So
infinity.
if we picked 10, 15 divided by 7, 2.5. No.
No, I mean, yeah, you can use the 10, but use the bigger values, not the smaller, that much smaller, like
700.
15,000, 7,000, or 700, even 700 will be okay.
Oh,
So,
because when it's bigger, it's a more exact value.
yeah,
Oh,
so
okay.
it will show you to which number it is approaching. Okay,
705 divided by 697 is
so it's approaching
s-
to 1, right?
yeah, it's
From the
1.
top, from the top, like 1.00 something. And if you will replace in same value in negative, like negative 900, and then x replaced by negative 900, so you will get 0.99 something. So it is approximately 1. Do you understand it? The vertical
Yeah.
asymptote and horizontal asymptote.
Yeah, I
Okay.
understand those two.
Next we have a positive interval. Yeah, this is called positive interval because 0 to infinity. 0 to infinity means 0, 1, 2, 3, 4. All these numbers, even 3.5, 1.5, 0.5, 0.9, 0. We even between any two integers we have infinite numbers.
Because infinite
Yeah,
possibilities of
yeah,
values.
yeah, 0.5, 0.005, 0.0005. So 0.0025, there are infinite values, infinite numbers between any two integers. So, but all these integers, all these numbers, integers and numbers will be positive. So that's why this is called positive interval. And this is also a positive interval for this function. Okay, a negative interval means we have to start from very big negative number like negative 1000, negative 900, negative. So it reaches to 0. 0 will be its last. Okay, and 0 is not included in it.
Because it's all negative values.
Yeah,
Okay.
and here negative interval, this one. Increasing interval. Increasing interval means how this function gives us bigger and bigger value as we replace negative to positive, like negative infinity to infinity. Like firstly, we replace negative 1000 in it. If I will place negative 1000 in it, what's the answer I will get? I will get negative 1000. Now, if I will replace negative 900, so what the answer I will get? Negative 900. So is this an increasing function? Yes, it is. As we are increasing the value of x, I increase the value, right? Negative 1000 is smaller than negative 900. Or you can say if I had the 1, x1, so function's value will also be 1. What function will give us? 1. If I will replace the bigger value of x, like 2, 3, so I will get a bigger number. So it's mean that, what is it mean? Function is increasing. And on which interval? From negative infinity to infinity. And this
So you
function,
can say in the Desmos, you can say from values. So if a graph is going up
yeah.
from intervals from x values 5 and over, how I want to make a graph that represents my idea,
Mhm.
but what I'm trying to say is imagine like a graph going to the right. So from quadrant 3 to 1, it's going that way, okay? So like a right curve going up. So from it's increasing from like whatever those values are. So it would be easier for me to show it to you if like if I could draw it.
Okay, you can use the annotation.
Uh,
You will see a
where
pencil sign, a pen sign, or
pen
annotation.
annotate. Okay, so imagine it's
Mhm.
like this,
Mhm.
and then we have 1, 2, 5.
Okay.
So then it goes like this, and then it goes up, something like that, right?
Yeah, got you.
So it's a it's an increasing interval from 1 to something like that, and then imagine it goes down again. So
Mhm.
between these two sections, it's increasing, right?
Yeah, even it's increasing
Okay.
here. Even it's increasing here.
Oh, the one, yeah,
Yeah.
below the y-axis, yeah.
Yeah, like if we have let's suppose a cubic function, a cubic function is like this, right?
Hmm.
So it is increasing up to this turning point. This point is called turning point. Like from here, the graph is turned. So from here to here, it's decreasing. This one will be its turning point. We will learn.
Wait, what's the two turning points? Maximum, absolute,
Yeah,
and minimum, right?
yeah. This one will be called as a maximum, and this one will be called minimum. There are many where like derivative we have to find out. That's a separate debate. Like we have to find the second derivative, and then we will decide which turning point is maximum and minimum. Firstly, we have to calculate the turning point, but that's totally
X
different debate.
minus X minus 1, no, N minus 1, right?
No, we will just find out
Degree
the
minus 1.
turning point. For turning point, we just have to find the derivative of the function. Like if the function is y is equal to x cube. Okay, let me make it easier. Let's suppose y is equal to x minus 3, x minus 2, and x plus 5. Okay. In this one, what will
Degree
be its
3.
Yeah, it will be degree 3 and it will be a cubic function. It will be like this, the graph like I sketch here. So now how we can find the turning point of it? Firstly, we will expand it. What will be its expansion? That's a separate
Should
debate. Okay.
shouldn't we plot the thing? Can I
You,
annotate if it's fine?
yeah, yeah, sure, sure.
So my way that I would approach
Mm-hmm.
this is I would plot these first. Is
Mm-hmm.
the A value positive here? Yes, no?
Okay. Yes, it
So
is.
a positive A value with an odd degree, which is 3,
Mhm.
would be Q1 to Q3, right?
Okay,
And
yeah.
then we plot the factors, the zeros.
Mhm.
So 3, what is this, 2? So -2,
Mm,
-5. And
okay,
it because it's Q1 to Q3, it needs to go like this.
yeah,
So because it's not quadratic, it doesn't bounce, so it would kind of look something like this,
yeah,
right?
it's true.
And to calculate the possible number of turning points, what
Mm-hmm.
I have learned is in this equation, we know that the degree is 3,
Mm-hmm.
so degree is always n. And the maximum number of turning points, the equation or the formula is n minus 1.
That's true.
Maximum number of turning points does not necessarily mean that there is only 2 turning points. It can be less than 2. It can,
Yeah,
so imagine if it's 5, it can be 4, 3, 2. It doesn't mean that it's always going to be 4, right?
yeah, exactly. Let me show you, let me give you the example of this. You explain it very. Okay, let's suppose if we have a x plus 5. Let me give you the example in which the function will be of degree 3, but there will be just one turning point. X plus 5 square, it's square. And if we take x in it, no, we have two turning point in it as well. X, let's take x minus 3.
Okay.
In this one, we have two turning points. One is at -5. This is a different kind of function. Like even this is a cubic function, degree 3. One turning point and second turning point. Yeah, even in this one we have. What if we'll take cube here? Yeah, here we just have one turning
Cubic.
point. Even still, its degree is 3. Still, degree is 3. But how many turning point? Just
1.
one. Yeah, as you
So n
said,
minus 1 doesn't apply.
yeah, as you said, n minus 2. So there will be two turning points. And then you said the condition like it's not necessary to be always two turning points. So this is the function. This is the example. You can say counter example of it. Okay.
Okay, I understand.
Okay. I think we are distracting from our topic here. This is decreasing interval, like the same debate in this one, like where the function is decreasing, in which interval it is going downward. That is called where its graph is going downward. Okay. So in this one, this function's graph will be on all values, it is going downward, right?
Because what do you mean from where?
From left to right, as we move from left to right in the graph, it is going downward. Let me show you. 1 over x. So as we are moving from left to right either here, so it is going down. Isn't this one going down?
Hmm.
And even in this one, if we are moving from left to right, even this is moving left to right. Left to right means x value from negative infinity to from negative to positive towards positive bigger number. So as we are moving uh, except 0, don't include the 0. So if the graph
So
is going down and down.
can I annotate for a bit?
Yeah, yeah, sure, sure.
So this one, like you said, left to right, and
Mm-hmm.
these are infinite values.
Mm-hmm.
So if it's decreasing uh like this, and then do you always put the asymptote value over here? So in this case, it's 0.
Yeah,
And left to right, so this is plus. I don't like I don't understand. this part? Like if it's left to right, then shouldn't it be something like this?
It's for this
Like
part.
for this part.
Yeah,
Yeah, for this
yeah, it
part.
is. It is.
Did
It
I
is.
do it correctly?
Yeah. So 0 to infinity. See,
Okay. All right. That's good.
this is a negative infinity to 0. So it is decreasing in the whole domain on the all values which we are placing in it. Okay.
Okay.
Like the function that I showed you before, um, x
X plus 5.
plus 5, or you can say, okay, yeah, let's take x plus 5 square, not cube this time, because in this one just there will be one turning point, so it will be not very clear. Let's take x uh, minus 2, or x plus 3. Oh, sorry, x plus 3. So if I want to check out the increasing or decreasing behavior of this function, where the function is decreasing from here to here, in this interval, from -5 to whatever the value here, that is, in this interval, it's decreasing from -5 to -3.66. Okay,
Okay.
from -5 to -3.66, it's decreasing. This is a decreasing. In this interval, the function is decreasing, because it is going downward. But
So if they
uh,
give us a question to
mhm,
state where the intervals are negative, how do you draw it? Like like you showed me in the bracket.
mhm.
If
Yeah,
they asked us to state where it's negative, so only for negative intervals, how do you do it?
mathematically or graphically? Graphically, we just have to observe the graph.
No, no, no. Like you just drew the bracket right here. So
Mhm.
if they were to ask, like if a question was there and they said just like solve it, like any x values between -5 to -3, it's decreasing. Is
Yeah,
there
it's
like a specific way to draw
math.
it?
Mm, like graphically,
Like like for a XCR of a domain, you can write it like this. So is there like a way like this, which would represent a negative interval, like a
no,
certain
no, no,
way to
no.
draw it?
No, it's this is the interval. Like always take the smaller value. Always like from left to right, we have to write the value. You mean to say, can we write -3.67 at first?
No, because that's increasing, right?
Yeah, we have to take increasing in x, but at in this interval, the function is how function is behaving. What's the function behavior?
It's going down,
Going
decreasing.
down, so it's decreasing. That's it. So we just have to represent like this. So in this interval, it's increasing, and in increasing, where this function is increasing? Function is increasing from negative infinity to -5,
-5,
and
and
then
then from -3.667 to positive infinity.
yeah, is it clear
Okay.
now?
Yeah, I understand.
Your question is clear as well, right?
Mhm.
Okay. Next, and behavior. Okay. This is the example. We have determined the equation in the form f of x is equal to 1 over kx minus c for the function with the vertical asymptote x is equal to 5, and a y-intercept at 0 minus 8. Y-intercept at 0 minus 8. Okay. y-intercept must be at 0 minus 8. Y is equal to 1 over kx minus c. Right. So firstly, we will find the value of k. Y-intercept means x needs to be 0, right? So x 0,
0.
y will be negative 8. So it will be 1 over minus c. So it means that what's the value of c?
-8.
No.
8. No, 1 over
Would it
c.
be c will be equal to 1 over 8, right?
Yeah.
1 over 8. This one will be the value of c. Okay, and what will be the value of k? So
-8 equal.
vertical asymptote. We need to replace kx minus c equal to 0. And here,
And then
what's
x
uh,
equals 5.
kx minus, we already get the value of c, that is 8, right? Is equal to 0, 1 over 8. Does this make sense or not?
Yep.
And after that, we will calculate the value of k, because only k is missing now. We already get the value of c. So just move the to the other side, and kx is equal to 1 over 8, and x must be at 5. So it will be 1k must be 1 over 40,
5 1 over 8.
right?
Okay.
Does this make sense, or should I have to explain it? I miss a step
No,
here.
we're just inputting the
The value
values,
of
no?
k. Yeah, I just replace the value of x with 5. Got it? So what will be the function? Final function will be f of x is equal to 1 over 40 x minus 1 over 8. This is the function. Its vertical asymptote will be at 5, and its y-intercept will be at 0 minus 8. If you want to verify, we can do on the decimal graphing calculator. So y is equal to 1 over
40.
1 over 40 into x minus, it was minus, right? 1 over 8. Okay, where it's vertical asymptote, you can see is vertical asymptote here at 5. It's 5. Okay,
So there.
yeah, and it's a y-intercept. Where is y-intercept? This definitely, this graph will never gonna intercept the y, right? Even it's not gonna cross the x is equal to 5. Even it's not gonna cross this line. So how it will intersect the y-axis? It will never intersect, right?
Mhm.
Only this graph is cutting the y-axis, means intersects with the y-axis at negative 8. That's all. Got it?
Okay. Yep.
Okay, now what we have next? Okay, this one. This is the just syllabus, right? Like chapter information. Okay, rational functions of the common. Okay, 3.2 rest.
Is
Okay,
that clear?
Yeah.
Are the
Okay.
values clear, or do you want me to screen share?
No, it's okay. It's okay. Even we don't have the time to start the next topic, so we will discuss in the next class, right?
When
It
can we
will
do
be
the next class?
if you are available by tomorrow, so you can. And this class was a demo lesson, so yeah. Okay, you can give a feedback, and after that you can tell me like if you want to continue with me or not.
Okay, thank you very much. I
Okay.
have a question. Would I have to pay for today's lesson? Because it's fine if I do.
You have to discuss with the person who is in conversation with me, like on my WhatsApp. Okay. So
Oh, okay.
who's there? You
I
Mo?
have no clue. This is my mom. Yeah.
Okay. Okay, then you have to
I'll
discuss with
talk
that
to
person.
her.
Okay. Yeah.
Oh. So I just want to ask you like one more question.
Yes,
Like
please.
so far,
Mm-hmm.
uh, I know you're very familiar with all of this stuff,
Mm-hmm.
advanced functions.
Okay.
What's like the main foundation that I need if I am to do this course to the best that I can? Because grade 10 and grade 11, like
Mm-hmm.
we went into the exam 3 weeks behind on grade 10 and 11. I didn't have a teacher for like a month because my teacher, her husband died from cancer, and we didn't have a supply teacher for 3 weeks. And then grade 11, my real teacher was on maternity leave because she was pregnant, and the
Mm-hmm.
supply teacher came and she didn't even teach us anything. So I just need to, if there is any help that you can give me, any tips, like reviews that I can do, what would you do if you were in my position?
We just like when you have exam,
My exam is it's January.
it's in January. Okay. And how much syllabus do you have left over there in this book?
We have like this up till unit 7.
Unit 7, and you are on Unit 3, right?
Hmm.
I need to check your syllabus. One second, let me check where it was. MH.
Also, when you look at MHF for you, look
Mm-hmm.
at Jensen math. Jensen math is the correct one.
Okay, one second.
Is it okay if I share my screen a little bit?
Yeah, yeah, that will matter. So I can check the
So
exact steps.
I'll send you this link as well. I'll put it in the chat. But this is basically it. Unit 1. Uh, this is what we are doing right now. So this is the correct thing. So this is just
Okay.
for Unit 1, and then review.
And
Where is it?
how in chapter number one and how you are in chapter number one and two? Like, are those chapters are clear? Are you good on in those chapters or
Hmm.
not? Hmm.
To graph everything, yeah, like I understand
Power
relations of function.
functions, polynomial functions. Okay.
Yeah,
Natural
like
compound.
a x from descending order. Yeah, degree is the biggest value. Okay, yeah. So all of this stuff, like, yeah, I already did this. Quartic, quintic,
Hmm.
where's the correct grade 9, grade 11, grade 12. Okay, here we go. So this is
Hmm.
unit 1, unit 2, uh, inverse of exponentials, which is what, and then radiance is the next unit. And then we go to trigonometry and instantaneous, so delta over delta pi, I think.
But
So
what
yeah,
is the
that's
chapter which we did today?
rational functions. Here we go.
It's chapter number 7. Okay. Okay.
So we just do it in different, like my teacher chose to do this one before, right? So it depends on the teacher, but I'll
Yeah.
also send this link to you.
Okay. So no, you have to tell me like how many chapters you completed. Like no, you are on chapter number 7, right? You are doing chapter
So
number 7. Mm-hmm.
in school, we have done 2 chapters, so 2 units. And the third unit we have just started. We are on 3.2. So there is how many lessons? I sent you a picture.
Yeah.
In the picture, there should be like a table, like a table of contents that
Mm-hmm.
should say 3.1, 3.2. How many things are there?
One second, let me check.
It should be the one on the left furthest. Yeah. So we are on 3.2 right now. We
Mm-hmm.
are going to do 3.3 tomorrow, and then we will have a quiz on Thursday, and then 3.4, 3.5, and then we'll have our test next week.
Okay. Don't you have a
So
proper book like here we have page number like definitely these
mhm,
questions will
that's
be
the
from the
homework.
book. Yeah. So it will be
Do
from the
you?
book.
Oh, I have the textbook as well. My teacher posted the whole textbook, so we can use that.
Hmm.
So
Yeah.
whenever, maybe tomorrow when we do the homework, we can use the textbook.
Okay, sure.
I can screen share it.
Okay, okay.
So you want to do the same time tomorrow,
Yeah,
or should I talk with my mom first?
it's your choice. If you want to do at this time, so that will be okay. Otherwise, we can do later. Uh, what's uh
And
what's your
this is
visible?
the textbook. I'm just gonna screen share for 1 second.
Hmm. I tried to find it out,
Uh,
but I think I didn't get this. Okay. Can you please show me its front page?
the first page, okay.
Yeah. So I will try to find it out.
It's called I have the book with me.
In
It's
PDF form?
just Advanced Functions
Mhm.
by McGraw-Hill Ryerson. So it's this one.
Okay. Okay, I will try to find it out this one if I will get this. So we will study from here as well. So then I will tell you like how much work you need to do more. Like at this situation, like I don't know how much syllabus you covered. Like you know about radians or trigonometry, or even I don't know like which topics you need to cover, right?
Yeah.
So I cannot tell you anything to be honest, like
Mhm,
how much work you need to do.
mhm.
If you have a final exam in January, definitely you need to cover all these topics. Chapter,
But I'm not late. Like we are on the same pace as our teacher so
yeah,
far.
yeah,
So,
yeah, yeah. As compared to school,
uh, but yeah, we can talk more about this tomorrow. I'm sorry
okay.
if I'm taking too much of your time.
It's okay. It's okay.
And what's your name, sir?
My name is Muhammad Khalim. Your name is
What do you
Amitesh,
want
right?
me to? Amitash, yeah. What would you prefer that I call you? Mohammed?
Yeah, you can call Muhammad or you can call Khalim.
Okay. Well, thank you so much,
Uh,
Mohammed.
okay,
You have a good one, okay, my
okay,
friend?
okay, sure.
Okay.
Okay.
Ciao.